How can we find the zeros of f of x equals x cubed plus 5x squared minus x minus 5? Recall that we set f of x equal to 0 and then we solve for x to find the zeros. So we can write 0 equals x cubed plus 5x squared minus x minus 5. This is the equation we have to solve. One question to start could be, what do these terms or some of these terms have in common? Let's try factoring out x squared from the first two terms and factoring out -1 from the second two terms. So we get x squared times x plus 5 in parentheses minus 1 times x plus 5 in parentheses. We see that x plus 5 is a common factor. So let's factor x plus 5 out and we get x plus 5 in parentheses times x squared minus 1 in parentheses. The equation is true when x plus 5 equals 0 or when x squared minus 1 equals 0. Because 0 times x squared minus 1 is 0 and x plus 5 times 0 equals 0. Note that we call this the zero product property. Feel free to pause the video and find out when x plus 5 equals 0 and when x squared minus 1 equals 0. X plus 5 equals 0 when x equals -5. Because -5 plus 5 equals 0. So the first zero of this function is -5. Now, how do we know for what value of x this equation is equal to 0? Let's bring the 1 to the other side by adding 1 to both sides of the equation. So we get x squared equals 1. X squared equals 1 for x equals 1 and for x equals -1. Because 1 times 1 is 1 and -1 times -1 is also 1. If you want one more step in between for the sake of practice, you can take the square root on both sides of the equation. Recall that when we take the square root, we get a positive and a negative square root as a solution. So we get the positive square root of 1, which is 1, and the negative square root of 1, which is -1. So the zeros of the original equation are -5, 1, and -1, and we are done with finding the zeros by factoring. By the way, the graph of this function looks like this. We see that each zero is an x-intercept. The graph passes through the points -5, 0, -1, 0, and 1, 0. If you like my videos, like, share and subscribe. Thanks for watching and happy learning, everyone.